if a total of 13.5 moles of sodium hydrogen carbonate and 4.5 moles of C6H8O7, which I think is citric acid, react per the following equation, how many moles of CO2 and Na3C6H5O7 will be produced? Okay, here's the balanced equation. What are they giving us? Okay, well, let's see. They want two different substances, so we'll have to have like a part A and a part B. So let's write down, like for part A, where they're asking for moles of CO2. So they're giving us moles of sodium hydrogen carbonate and moles of citric acid. Which one of those is a given substance? Wow, this is a curveball for us. But keep in mind, okay, 13.5 moles is really 3 times 4.5 moles. So what they're saying here is you've got 3 times as many moles of sodium hydrogen carbonate as you have citric acid. Well, that's good because that's what the balanced equation would require. 3 times as many moles of this sodium hydrogen carbonate as this citric acid. So you can really pick either one of these, okay, to be a given. All right, let's say for moles of CO2, I'm going to pick for part A, in other words, where they're looking for moles of CO2, I am going to pick this as my given and moles of CO2 as my wanted substance. Okay, so let's start off by our given substance. 13.5 moles of this. 13.5 moles NaHCO3. Okay, so again, it's a mole-mole problem. We're just going to take the moles that they give us, multiply it by a mole ratio, get the moles of what they're asking for. So we're taking 13.5 moles of NaHCO3, multiplying it by a mole ratio of wanted over given. That would be 3 moles of CO2 over 3 moles of NaHCO3. Okay, moles of NaHCO3 cancel, and they're asking for moles of CO2. Well, if we do the math here, we'll get moles of CO2. Well, 13.5 times 3 divided by 3, guess what? It's 13.5 moles of CO2. That's the answer to part A. Okay, and they want to know how many moles of Na3C6H5O7 will be produced, which looks like sodium citrate. Okay, B, moles of Na3C6H5O7. That's what they're looking for there. So now the wanted substance isn't CO2. Now the wanted substance is this stuff out here, Na3C6H5O7. Well, same approach. Let's start by writing our moles of given. 13.5 moles of NaHCO3 times mole ratio, wanted over given, so, well, I can't even make a 1. 1 mole of Na3C6H5O7 over 3 moles of NaHCO3 NaHCO3. Okay, moles of NaHCO3 cancels with moles of NaHCO3. And just as a reminder, we're doing a mole-mole problem, so we don't need all this other stuff out here. 13.5 times 1 divided by 3. I have a sneaky suspicion I know what it's going to be. 13.5 times 1 divided by 3. Yep, 4.5. 4.5 moles of Na3C6H5O7. That's the answer they're looking for. Okay, now let's notice something here. They're giving us 13.5 moles of sodium hydrogen carbonate, 4.5 moles of citric acid, and they're asking how many moles of CO2 will we get and how many moles of sodium citrate will we get. Well, moles of CO2 end up being the same as the moles of sodium hydrogen carbonate, namely 13.5, because look at the coefficients. 3 there and a 3 there. So you know that however many moles of sodium hydrogen carbonate you start with, you're going to get 3 moles, you're going to get that many moles of CO2. So that's why this number and this number are the same. And then look at sodium citrate. Well, it's got a 1 coefficient versus this 3. Well, and actually this citric acid has a coefficient of 1, which is the same coefficient on our wanted substance. So since you had 4.5 moles of this, you can expect 4.5 moles of this, which we got. So isn't that nice?